オーラルプレゼンテーション3、バイオマスの熱分解により発生したエチレンガスの中赤外線による濃度測定。大阪桐蔭高等学校の皆さんです。どうぞステージへお進みください。泉博穂さん、大西克文さん、川崎洋平さん、福田義孝さん。指導は中島哲人先生、木下光一先生、有馬実先生です。それでは皆さんどうぞよろしくお願いいたします。
Today, I'd like to talk about the new method to measure the concentration of ethylene via mid-infrared laser and about the biomass pyrolysis to get ethylene gas. Now, I'd like to show you the introduction. When measuring the concentration of ethylene, gas chromatography is used in general. However, it takes a lot of time. It is known that ethylene gas exhibits the absorption in 3.2 to 3.4 micrometer with infrared laser. Then, we'd like to develop the faster method for measuring by using mid-infrared laser absorption. That is black liquor. Nowadays, black liquor is banned in thermal power plants. But it is known that liquid fuel is got by rapid pyrolysis of wood scrap. Then we considered that we can get ethylene by pyrolysis of black liquor, which is generated when wood turns paper.
Research 1. Develop a new method for concentration of ethylene via mid-infrared laser. First, we tried to measure infrared light from heater with a voltmeter by infrared ray sensor, but the voltage responded only a little, about 1 millivolt. It couldn't measure the concentration of ethylene. So operation amp was used. It can change an electronic current to the voltage. Next, the acrylic absorption tube. The side windows are a problem. First, acrylic plate about 2 mm was used for both sides. There was no optical response. Acrylic plate absorbed infrared light. Next, the polyethylene film was used. It was very thin, 0.08 mm. It was difficult to glue at the window. Then the cover glass for microscope was used. In this case, the infrared light response was measured. This is the diagram of experiment method. Standard gas was put in the acrylic absorption tube from the syringe. The incident light was measured at the voltage by operation amp and was discovered at a PC. This was the experimental stage. First, we used 11.5 cm and 4 cm acrylic absorption tube. Vertical axis was the intensity of infrared light. This is at no ethylene. Incident light intensity I0. Various concentration of standard ethylene gas was put into the tube. This is the transmitted light intensity I. It was smaller than incident light intensity I0. These tables are the results. As various concentration from the incident light intensity I0 and the transmitted light intensity I, the absorbance was calculated using log I/I0. The vertical axis is the absorbance and the horizontal axis is concentration of ethylene. The result of relation between the absorbance and the concentration of ethylene wasn't straight line. It was not a law of Lambert-Bell. Then we changed the 4 cm acrylic tube to 2 cm. The vertical axis is the horizontal. This figure shows the voltage. This relation is not linear. We think this is probably because the sensor was detected as a light, not from ethane absorption tube. From this hypothesis, the light intensity which responded to the ethane was smaller than the observance intensity. So we corrected the intensity. The intensity offset was 139 millivolts. After correcting the proportional, the concentration of enough good. This means that the liquid light not from acrylic tube were observed by infrared sensor. Then we protected the cell side with black plastic tape in order not to leak other light. As a result, improvement of reference curve was much better after protection. By this square method, we could get the linear relation of ethane concentration between 0 to 50%. By adopting this relation, we can measure the concentration of the ethane. This is conclusion. It is possible to measure the concentration of ethane via mid-infrared light.
Research 2, pyrolysis. First, we explain method. Look at following figure. Sample was put into the side flask and then sample with the light was put in it. The gas was collected overall. The amount of ethylene was measured by infrared lasers. This table shows outline of control experiment. This picture shows actual condition of our experiment. The flask was surrounded by steel plates and heated infrared hot plates. The vertical axis shows voltage. We measured concentration of ethylene from the calibration curve in research 1. This graph shows calibration curve from research 1. The vertical axis shows absorbance, and the horizontal axis shows concentration of ethylene. This table shows calculation diagram. Every row is sample number, and the column is value. The intensity of incident light was almost the same. We calculated absorbance from this intensity. We can get concentration by using calibration curve. This graph shows the amount of generated ethylene from cedar further. The vertical axis shows amount, and the horizontal axis shows temperature. The amount of ethylene from black liquor was formed. The amount of ethylene from cedar further with nitrogen purge was larger than without nitrogen purge. This is because sample with nitrogen purge was heated rapidly. According to this result, the amount of ethylene from cellulose was largest, especially with natural cellulite. Research 3, concentration measurement after pyrolysis by gas chromatography for gas detector tube. The concentrations of ethylene in generated gas from cedar or black liquor were measured by gas chromatography. The amount of carbon dioxide was calculated by the difference of total gas just after pyrolysis and after 2 weeks. This figure shows the result of gas chromatography. Detection time is set on the horizontal axis and intensity on the vertical axis. According to gas chromatography, the included hydrocarbon gas was only ethylene. The vertical axis shows the concentration of ethylene measured by gas chromatography. The horizontal axis shows concentration measurement by infrared laser. This graph shows there is almost no difference between measured by gas chromatography and by infrared laser.
This graph shows total amount of generated gas. The vertical axis shows the amount. The amount from dry breaker was less than 1,100 milliliters.
This graph shows the amount of generated carbon monoxide. The vertical axis shows the amount. The amount of carbon monoxide considered for filter paper were large. On the other hand, these from black liquor or lignin were small. This is derived from CHO bond. The amount of carbon monoxide from lignin with natural zeolite was the smallest. This graph shows the amount of generated carbon dioxide. The vertical axis shows the amount. In the case of black liquor, the amount of carbon dioxide from non-dried one is larger than that of dried one. This is because some carbon dioxide was generated in drying. Here, conclusion. The sum of the amount of these three gases was not the same as the total amount. This means other gas was generated. With the smaller zeolite, the less malodorous substance was generated. Here is future work. First, carbon monoxide or carbon dioxide gas is with the absorption in far infrared light. So we would like to develop the measurement instrument as well as that of ethylene. Second, to examine why ethylene was generated from lignin or cellulose, we would like to have other examinations with different substances. Finally, polyethylene is synthesized from at 10 atoms now, but this method takes a lot of time. So we would like to find the new catalysis and synthesize polyethylene from ethylene at 1 atom. Nowadays, black liquor is banned in thermal power plants. However, black liquor, which contains a lot of lignin, may be the supplemental source of ethylene. This can contribute to reducing oil consumption. In the near future, a lot of biomass may be pyrolyzed at not so high temperature. Ethylene gas can be gathered, and then polyethylene will be synthesized from the generated ethylene. This is expected to contribute to low carbon societies. Here is references. Thank you for listening.
ありがとうございました。それでは次、応答のお時間とさせていただきます。ご質問のある方、挙手をお願いいたします。はい、ではマイクをお願いいたします。
I'm Kozaki from Osaka State University. My question is, you said beginning of your first part of your talk, you said you can get a linear relation between the concentration of ethylene gas and the intensity of absorption due to the absorption of the other gas. But usually the number very low can use under the condition of low concentration. Can you check you can apply that law under the high concentration condition?
You mean research one?
Yeah, my question is, you can get a linear relation, especially the condition when you use a higher concentration of ethylene gas. Okay, but the condition under the higher concentration, can you use a Lambert very low, or it's not good to use that condition is not good to use Lambert very low? Did you check it?
Thank you very much for your question. I think because the incident light, which can think I was reaching infrared light sensor from outside directly. This time could be cut by covering a pipe with reflective. Therefore, even if 139 millivolts wasn't reactive, ABS and the concentration of ethane was straight line relationship.
ありがとうございます。それではお時間が参りましたので、質疑応答以上とさせていただきます。大阪桐蔭高等学校の皆さんでした。ありがとうございました。